Now, unfortunately, this whole thing of sticking a 50 milliseconds in here doesn't make a lot of sense to us as humans. Like, that's just not how we think about time or game frame rates. What's going to make more sense instead is to calculate that to be something we can depend on, like games often like 30 frames per second. Since we're about to be doing a lot more updates a lot more rapidly, let's get rid of this console log for now. And let's change set interval to calculate that value. Let me zoom in on it so we don't see the program doing its old stuff. I'm going to say var frames per second equals 30. And now instead of saying 50 here, I'm going to divide 1,000 or 1 second worth the milliseconds. I'm going to divide it by frames per second. Okay, so that means that if we had 1 frame per second, it would make this 1,000. If we wanted 2 frames a second, that'd be 1,000 divided by 2, or 500. And so this allows us to think in terms of how many frames per second do we want, and then the calculator will compute it for us. Notice too here that I'm doing this var here, right here before I use the variable, inside of window onload, not out here in the script, which has a little different behavior. This means that this number will be forgotten by the time that the end of this function gets reached. We don't actually need to ever call this variable label, frames per second, inside the draw everything or anywhere else in our code. We just need it for this next line to do this calculation. And it's nicer this way because now we were able to put a label on it. Instead of typing out 1,000 divided by 30 and later looking at that and trying to figure out, like, what did we mean by that? We were able to put a word on what that number means to us. So this makes some sense to us that, okay, that's going to be used to calculate our frame rate. Is that making sense? But see, this makes it a temporary local variable. Now, the reason why we couldn't do that with balx is because we need this number in the other parts of our program, and we also need it consistently remembered by the program even after the function finishes. So if we declare a var inside of a function, it gets forgotten as soon as the function ends, when it reaches the closing brace. By defining it out here and setting it up out here instead, it'll be consistently remembered, so when we add 5 to it and save over it, it'll keep that change and store it and remember it outside of the scope or outside of the functionality of that one little function. So when it comes back and happens the next time, every 30 times per second, it'll be working on the same value. So let's see what that does. Zoom back out, save our file, refresh, and now we have a pretty smooth red ball moving along the screen. But let's make this white rectangle more like where our paddle should be. We want it on the left side of the screen. Maybe instead of 225 pixels, remember this is how many pixels it is from the edge. If we put it at 0, that's going to have it square up against the side. Let's check ourselves. I save it, refresh, white rectangle's up against the side. Vertical position, don't really care about. It's going to be controlled by the mouse later anyway. How wide do I want this shape? Let's say 10 pixels thick, because I want a tall, thin shape for our paddle. I'll save it and refresh. I have a taller, thinner shape. And how tall do I want it? 200 seems a little too easy to play. Maybe 100 will give me more of a rectangle size I want. It looks more like a reasonable tennis paddle for these kind of classic games, right? One of the things, though, that's going on here is that we're actually mixing together our movement code and our drawing code, which at some point down the line can come back and bite you. And the reason for that is because, like, we don't want to be drawing half of the things, then moving them, then doing calculations based on their positions for other stuff, and then drawing. We want to have everything update its positions all at once, all the paddles, all the balls, everything else, or, you know, depending on the game, all the spaceships and warriors and projectiles and magic spells. We want all that to calculate first, and then draw all at once as a coherent chunk of code what the update is and what it looks like when it surfaces it to the player. So let's split apart. Instead of just having everything and draw everything, let's move our move code into a separate function, which we will call function move everything. And I'm just going, let me zoom in for you. I'm just going to cut this with Control X and paste it into move everything. So now I've got a separate function for putting my movement code from my draw update code. And now I want to update this set interval call so it'll call not just draw everything, but both of those functions. And the way that we can do that, I'm not really using a lot of specialized JavaScript stuff here, but I want to show you the thing we can do. If we have a very small, simple function, we could define it elsewhere, just like we did draw everything. So we could say function call both. And in here I could say move everything, draw everything. Notice that these functions always have these parentheses after. We can explain later how those are useful. You'll see it when we move our shapes out. And then I could put this label call both right here instead of draw everything. If that makes sense to you and that's how you like it, that's totally fine. But think about this. Are we ever really going to go back and change this function? Do we need that to be its own separate thing floating around in our code? Like, we're always going to want to call move everything and draw everything once per frame, and just like that fashion. We don't need to complicate it any. We don't need to go back and maintain this. So it doesn't really need its own function. We're never going to call this function call both label from anywhere else. So there's another way to do it in JavaScript, and I'm going to show you right here. I can define it in line. I'm going to say function, open and close braces. And right here, I put the same guts of that call both function. Copy and pasting, or cut and pasting. Get rid of call both. And what I've done here is I've defined inline right there in the code that I want to be calling move everything, then draw everything. In any code we want, we could throw a console log in between these. We could call other functions, except this function doesn't have a label and can't be called from anywhere else. So if you have a really small, straightforward function, you don't have to change much. That's an option. You can do that in JavaScript. It's technically also kind of the syntax you're seeing for this window onload function, if you're curious as to how you're seeing that. It's not how we're going to define most of our other standalone functions, but it's something I want you to be familiar with in case you start seeing that kind of thing in other code you look at when you find JavaScript examples out there on the web. Next up, we're going to change that red rectangle, red square, into a ball, and then we're going to get it to bounce off the edge of the screen. So stay tuned for that. Got more of that in just a moment.